Hello everyone, welcome to day 3 of 5.3. We're going to be continuing with graphing cubic functions with transformation. So we're going to be modeling with the transformation using the real-world situations involving cubic functions. So here is the first problem. We're going to give you a formula, some tools so that we could use with the real-world situation. So here's a formula that you may or may not be familiar with. If you're taking chemistry, this should ring a bell, that density is equal to mass over volume. So that's a formula that we're going to be involving and using throughout the lesson today. So here's the first formula. And let's take a look at the first example. Estimate the radius of a steel ball bearing with a mass of 75 grams and a density of 7.85 grams per centimeter cube. So we call that the volume. If you need to look up, you can Google this if you want to. You don't know the formula, but here it is. The volume of a sphere, which is a circular 3D shape, correct, is 4/3 pi r cubed. Do you guys remember this from IM2? We learned this in IM2, the formula. So we are also given the formula density because it's talking about density specifically, which is why we gave you this formula to start with. So density is given by the mass over the volume. And the volume part is when we need to use this formula right here. So that's why we are going to make use of that. So we're going to substitute the density that is given, which is 7.82. And we're going to also, the mass is given and substitute the mass in here. And the volume is going to be 4/3 pi r cubed. So basically, we're going to need to solve for r in this case. So this is kind of a little bit complicated for a fraction. So what we're going to do is just draw one underneath here, and we're going to treat this as two separate equations and cross multiply. So now on one side, I have 32.76 radius cubed. And I've already approximated using pi to get this answer here. And then on the other hand, I have 75. So now what I need you to do is go into decimals. So use decimals and enter two separate equations. So I want one equation to say y equals 32.76. You can just use x for r. And then other equation use y equals 75. And as soon as you finish that, you will be able to find two equations. And so I believe one of them is at y equals 75. So I'm just going to draw the line approximately like this. So you should see this line on your decimals when you enter it. And then the other one is a cubic function. So once you enter it, it's going to look something like this. And it's a cubic function, so it keeps going. And then you're going to click on the point where they intersect. So it looks something like this. And so I'm just doing an approximate graph here because it's not accurate at all, but it's going to be like something like this, and you're going to click on that point on decimal, and it should give you the exact point for the intersection, where they intersect, where they meet. So the radius is approximately 1.3 where they meet, and that's going to be, the unit is centimeters. So that is how you will find the equation. Another way you could just do is you could simplify the equation a little bit right here by dividing by the 32.76, and then you have r cubed is approximately 2.289. You can enter that also separately, and you should also get the same approximate answer, which is 1.3 centimeters. So the answer is 1.3 for the radius. And that is the end of this problem. Next, we're going to look at a different problem. A bead filled a cube-shaped box with an effective density of 0.00076 kilogram per centimeter cube. The filled box weighs 6 kilograms, while the empty box had weighed 1.5 kilograms. And it says hint, the volume of a cube is x cubed. So if we're only talking about the inside, we are going to actually need to start with the volume. So the volume of a cube box is x cubed. That's the hint. And again, using density equals mass over volume. Now I want to talk about the mass a little bit because it's actually talking about what's filled inside. So you want to exclude the box itself. It says the empty box weighs 1.5. With the material, it weighs 6 kilograms. So we want to remove the box. So we're only talking about the content, which is inside. So it should be 6 minus 1.5, which is 4.5 kilogram. So now the density is given. We're going to substitute 0.00076 equals to the mass, which is 4.5 for the content only without the box, over x cubed. That is the formula for the volume of the cube box. Again, cross multiplying, we will have 0.00076 cubed equals 4.5. And at this point, again, I want you guys to enter two equations, one on the left, and then both y equals to separately, these two equations, and on decimals. So go to decimals right now and follow along and just enter those two equations. And you should see something like this. So y equals 4.5, which is like right there. It should be a horizontal line across. And then the next one is going to be the cubic function, which something like this. So you want to see something like this. And then again, you have two equations. You can zoom in or zoom out and then click on the point where they intersect. This is going to be your x value. So whatever here is lined up to, it's going to be your point of intersection for the two. So if you do it correctly, you should have x is approximately 18, and the unit in this case is centimeters. So the radius or the inner edge of the box is 1.8 centimeters. And that is the end of the problem. And looks like that is the end of the lesson as well. This is the end, and you need to go into Google Classroom and get started with your homework. Have a good day.